My name is Borja Burgos, and today we're going to be talking about shift left using observability in the development process. I've got Paul with me. Want to introduce yourself?
I'm Paul Vecchio, manager of foundational technology at Sweetgreen. I think my mic's not on. Test, test. Can you hear me?
See if you can play with the volume. It's on this side.
Yeah,
I don't see the test.
closer to your...
Maybe they're holding it up there. Yeah, give it a try now.
Test, test. Yeah, there we go. Hi. All right. So, hey, I'm Paul Vecchio, manager of foundational technology at Sweetgreen.
And as I said, I'm Borja Burgos. I'm a product manager at Datadog, overseeing our CI/CD visibility suite of products. So today, as I mentioned, we want to talk about shift left observability. Before we jump on that topic, I want to give you a little bit about, tell you about me, only really because it's somewhat relevant, and I've got some interesting anecdotes to share about my background in this space. I started working in the developer tool space about 10 years ago in a small startup called Tudum. We were building a container platform for developers to run their containers, something that we take for granted today that most cloud providers give us. You go back in time 10 years ago to 2013, 2014, it was not as trivially easy to deploy your containers in the cloud. That took me to Docker, and that's where I saw some of the challenges around the lack of observability in development that we're going to be talking about. At Docker, as you very well know, we were building complex technology. We were building distributed tools and distributed systems. One of those tools was Swarm, which was an orchestrator and scheduler for containers, very much like Kubernetes, but better. And one of the challenges in building Swarm was that it was a complex distributed system, right? So what bugged me in a way is when we had an outage in Docker in production, we actually were really good at figuring out what had happened. We had telemetry, our metrics, structure logs, distributed tracing, error management. So when something failed, we had engineers on call. They would take a look at it, and within minutes, we had figured out what was the root cause behind that. But during CI, when we were building these technologies, our CI would break, and we would actually spend many, many hours, sometimes days, before we were able to figure out what had we broken. The reason for this, we were oftentimes spinning multiple nodes, hosts, across different cloud providers, and we would run a series of tests, and then things would break, and we would ultimately really only had access to the logs from Jenkins, and we had to figure out what was breaking by looking and parsing the logs from Jenkins, and it got so bad we had engineers on call to fix our CI. And I was thinking, we're so good at fixing our production systems, but we're so bad at figuring out what's happening in our CI system. But we've got all these great tools and technology and best practices. Why don't we just use that to figure out how to fix our development? So I left Docker to start another company in this space called Undefined Labs. We built a small product called Scope around test and CI visibility. And ultimately, that's what brought me to Datadog, where I am today. So what is shift left? What do we mean when we talk about shift left? Quick detour. Did you know that supposedly the left twigs and the right twigs are different? I just learned this not long ago. I think it's all a marketing thing, but it has me thinking. So what do we mean by shift left, right? We're not talking about twigs, the left twigs or the right twigs or which one's better. We're talking about this graph, which I'm sure most of you have seen some iteration of this infinite loop, right? On the left-hand side, we have development, and the right-hand side, we have operations. This is the software development lifecycle, how you go from development ultimately to deployment and back to development. So when we're talking about shift left, for those of you that struggle with right and left, very much like I do, we're talking specifically about that half of the infinite loop, right? The development part of it. And when we're thinking about shift left observability, we're thinking about how do we bring observability best practices, observability tooling into this half of the loop. And this is akin to other things that you may have heard: shift left testing, shift left security. Shift left testing, there's a lot of tests that we run later in that loop. Think about your user acceptance tests, your end-to-end tests, QA tests. What happens when you start running these tests early in the development workflow, you start detecting regressions earlier. The earlier you detect regressions, the more easily they are to fix. Similarly with shift left security, instead of waiting last minute until you have things running in production to run your security test, you start doing things around, say, your dependency tracking, vulnerability management, static analysis in the development workflow so that you can detect these regressions earlier. And as Paul will talk about later, the earlier you detect these issues, the cheaper it is to fix them, and ultimately the faster you're able to build and deploy software. So everything when we talk about shift left, we're really talking about enabling the production of high quality, low-cost software in the shortest possible production time. Really, that's what it boils down to. We want to build great software, we want to do it fast, and we want to do it cheaply. So, as part of my talk, I've got a few anecdotes that I've seen throughout my career as to how shift left observability has helped me and my teams resolve issues and understand regressions and prevent regressions that would otherwise have been harder to fix without applying some of these observability principles. So I'm going to touch on a few of these anecdotes, and then I'm going to pass it over to Paul to tell you more about how him and his team at Sweetgreen use observability in the development workflow. So one of these first anecdotes is around building a container image. One day, we have a developer that needs a package that our base image, we were using one of those minimal Linux distributions, was not in it. So innocently, he goes and changes the base image to a stock Ubuntu image. From one commit to the next, all of a sudden, we are shipping to production a full-fledged 2.6 gigabyte image, whereas we were shipping for a 230 meg image. Now, the CI passed. It built, it checked out, all the tests run, everything was good. It wasn't until a few weeks later where we were like, I think our network bill went up from distributing all these images, and our deployment process actually was a little slower. From having to we're deploying so many times a day across so many pods, downloading an image that's 10 times bigger actually has an impact. So I asked the team, how could we have prevented this? Is there a way in which we can apply observability principles to have fixed this? And very simple. We said, what if we emit a metric on every build? We create a metric that's ultimately the byte size of whatever artifact we're building, whether it's your jar file or a binary or a Docker image. We calculate that byte size, we emit a metric, and send it to our observability platform. And then we create a gate. That's basically the gate says, calculate the average of this artifact, the average size of this artifact over the last 30 days. And if a given commit increases that size by, say, more than 20%, break the build. Very simple. And now anytime somebody decides to change the base image or import a new package that causes an issue like this, that build fails because we have the ability through a simple metric to break this and prevent this type of regression to land in production. Another anecdote, another thing that happened one time, and another developer was adding a new column to a list table that we had in our product. So he changed the SQL query to be able to get that attribute of the element that we were displaying. The code review went fine, and this landed in production. Now, that SQL query went from 100 some milliseconds to 700 some milliseconds. So a significant regression. Now, we had unit tests, we had integration tests that were in place. But once again, everything passed. The CI, the build itself wasn't significantly slower. No one's going to notice a build that takes 600 milliseconds more. But the impact that this change in the SQL query had in production, that we felt. So we had a few weeks later, a user like, hey, this table seems to take a little longer than it used to load. Oh, let us take a look at it. Sure thing. You know, within minutes, we look at that. Oh, that query, yeah, there's an issue here. Fixed, done. Wouldn't it have been easier to fix this in development? So what did we do? We now calculate timing for all of our tests. Every test, we store that, the timing information. And while there is variance in CI, it's easy to say, you know, if for any given test, if the duration of a test is 20, 30, 50%, 3x more than the historical average, even if the test passes, still we want to fail that build because it's likely that a regression was introduced. You can also do this for benchmark tests, which are better for this type of scenario, but you could use timing information for this, and we have done it with some success. So that's what we've done, and you know, now we get notified whenever we have a regression in performance that where the test didn't pass, didn't fail, but the regression was there. And the last example that I have as to how you can use some observability principles for in development is around integration tests. What we did, we had a number of integration tests that when they failed, they were very hard to debug. So we brought in OpenTelemetry, distributed tracing, into our integration test. So what you're seeing on screen here is a distributed trace, but this is not an actual request. The top span is actually the test itself. And everything underneath are the requests that are spanning from that test. So if a test is making HTTP calls, gRPC calls, SQL queries, those get represented in this distributed trace. So when the test fails, instead of saying, you know, error 500 from my next hop in the network, I can actually see where the issue stems from. And if it's 5, 6, 7 services down the stack, I can see the error that that service is throwing in the context of the test execution that manifested that regression. So this is great for debugging. As a developer, I no longer have to try and fish logs from different services. I can also send this trace to the team that owns that service and say, hey, you know, I was running this test and I'm seeing this error. So this cut down our mean time to resolution of failed tests significantly. So these are just some examples as to how you can use observability tools and best practices in the development to catch issues earlier, to reduce your mean time to resolution, to increase the mean time between failures in CI, and ultimately to build better software faster. But to tell you more about how they're doing it at Sweetgreen, how Paul and his team are using some of these principles, some of the challenges that they have seen at Sweetgreen, I'd like to again invite Paul back to stage to tell you about shift left observability at Sweetgreen.
Thank you, Borja. All right, so before jumping into some practical examples of how we do observability at Sweetgreen, I'd like to just discuss a little bit of what foundational technology is. So foundational technology, it was a combination of 3 separate domains at Sweetgreen: developer experience, quality engineering, and site reliability engineering. And what we noticed is that all three different teams were kind of going in the same direction. There was a couple overlaps, and the solutions that they were producing, while useful to the organization, didn't actually solve the complete problem of the organization. So pulling in all the teams to a single domain and having them work on a cross-domain problem together ended up resulting in better productivity solutions for our organization, higher quality software, while also simultaneously reducing the cost. And some ways we've done that was researching and implementing tooling, frameworks, and processes that the rest of the organization can leverage to enhance their performance as engineers. So again, before going into practical examples, I want to set the stage in 2021, where Sweetgreen had 3 separate code bases for its order application, how you can submit an order to get a salad. That was across web, iOS, and Android. We had limited engineering capacity, so we were being asked to do more with less, and we had a core app that was written in Ruby, and we had little in-house experience with this application. So what did that mean to our organization? Well, each time we needed to implement a feature, it had to be across 3 separate code bases. When we had a triage, a ticket being submitted by a user, again, find out which platform it was on, whether the regression was on 3 separate code bases, and then fix it, and then deploy it. And that wasn't really sustainable, because like what got us to where we were wasn't going to get us where we wanted to be. So Sweet Green that's foundational technology, along with the rest of engineering, took a step back and decided, well, what can we do to enhance our developer processes? Well, we clearly were investing in monitoring and alerting, infrastructure as code, our testing frameworks, moving away from a unified tool to more targeted for each platform that we had because there were some performance issues, as well as taking a step back and looking at our service architecture and highly investing in continuous deployment. But the two big bets that we made were moving to a monorepo to basically consolidate all of our repositories into a single space for our developers to collaborate, and then also consolidating our development framework for the Order app into a React Native application using Expo, which simplified the developer experience. And this led to a massive greenfield project called replatforming. And as mentioned earlier, it was a rewrite of the Order application in React Native, which led to sustainable development and a unified code base. It led to some developer joy. The organization got a pretty big boost of morale because we were working on something that was completely new. There was freedom to working in a new repository, and we were learning while doing, which is very, very fun to do as an engineer. And we got quicker feedback loops and a massive increase in productivity. This led from a proof of concept to a 3-platform release in just about a year and a half, and this was a big impact to our customer experience. But it wasn't all gravy. As we were getting closer to our production release, we noticed that our productivity was dropping. Because we invested into observability, into our CI pipeline, we were able to see that the rate of commits were dropping, our testing pipeline was failing more often. It was passing roughly 60% of the time, which was blocking merges to main, also increasing the batches of changes, making it into production, which would then yield a worse customer experience because you weren't doing bite-sized commits and incremental learnings from your product development. And this also demotivated our developers, where getting something into main, they lost trust in our testing pipeline. It wasn't expected to pass. So retries became common, blaming tests for being flaky, where there are actually really legitimate issues in the pipeline that could have been caught were being passed because we weren't trusting our software. And developers are actually asking for manual quality gates to push out software into production, which is a regression from continuous deployment. And we don't want to see that as an enablement team at Sweetgreen. So moving on, why did this happen? Or what is the cost of releasing software, or as a bug makes it all the way to production? Well, what we were seeing on this graph is you can see as you're moving down the software development life cycle, the cost of fixing a bug increases. This also impacts the customer experience, because if you're trying to reorder a salad and the application isn't allowing you to reorder a salad, well, you're also impacting the monetary impact of the business, where the experience is worse. You may not want to reorder the salad, and you're now losing money as a company. And going back to continuous delivery, well, to really make that work, or continuous deployment, to really make that work, is you got to make this intersection extremely seamless. If your tests aren't passing and you don't have the observability needed, well, you end up creating a negative feedback loop, which is going to decrease your iteration capabilities and also reduce the product quality that you release to your customers. So we noticed this, and we're like, okay, we got to slow down. We need to reevaluate our testing pipeline. Why is this happening? And invest some time shoring it up for the rest of the organization. So many of you probably have gone through this experience in your organization, where you look at your unit tests and you're like, okay, there's some issues with it. We can fix it. It's not that big of a deal. Move on to your integration tests. A little bit more effort. Maybe there's some setting up and tearing down that you have to do to make it a little bit easier. But then you move to end-to-end tests, and if you've ever seen that testing pyramid where end-to-end tests are the most brittle tests and also the most difficult to maintain, that's a really overwhelming experience when you're about to release a product to all of your customers, and the pipeline isn't necessarily stable. So we had to figure out a way out of that. And some of the issues we were running into where we actually had our WAF blocking our API tests because we were using Circle CI, so requests going into our development environment were being rate limited, so that was one of those issues we had to resolve. We had unreliable third-party environments where, because we weren't able to test in production, the environments we had, which were sandbox environments, couldn't handle the load or were actually actively changing beneath our feet, along with misconfigured like mobile simulator environments. And one of the major differences for Sweetgreen end-to-end testing that I've noticed is that we actually use the point of sale in our end-to-end test, where a order submitted through the application, through all the APIs, to the point of sale, and then you print up an actual chit, which is the order that the team member creates for the customer. So we had to get out of this negative cycle and also attack the end-to-end tests in a way that was sustainable for the organization. So what do we do? Again, many of you probably have gone through this cycle where we selected a test, fixed what we could with that test, and quarantined the ones that we couldn't so that we could observe the performance of those tests in our pipelines, and then observe stability for the ones that we fixed, and then slowly introduce these tests into our pipeline to make them blocking for a release. And how did that turn out within the organization hours we were making these tests? So cumulatively, these are all the tests running in our build pipeline. It was about a 7-day average of cumulative build time for the organization. And as we were improving our testing pipeline, we were reducing the time it took our pipeline to run so that we cut it basically roughly in half, while simultaneously increasing the quality, because even if you do reduce the build time, you can basically just have tests that fail faster, but don't actually improve the reliability of your testing pipeline. And as we were moving up from 60% all the way to 94%, we noticed that developers were gaining a little bit more trust into our deployment pipeline. They asked for the manual process of deployment was going away, and we were able to incrementally make changes to our repository a little bit quicker, as opposed to before where they were basically being gated changes. Now moving into a practical example of observability, we had a migrated service we're moving from Elastic Beanstalk into ECS. This should have been essentially like a no-op change, it's just changing the host of where it is. But as we were developing this application, we noticed that our bill for AWS, for specifically SQS, was starting to double, then triple, then quadruple. And this was a little concerning, but since we had the observability for our pipeline, we were able to notify the team that, hey, this is going up. And what it ended up turning to be is a short polling issue on SQSQ, where essentially we're doing 100,000 empty receives per minute on the service, and moving to long polling dramatically reduced the cost of this running service. And now I would like to talk about a gap in our observability process. We had our entire pipeline had metrics, tests, observability in production, but for one of our services, we weren't getting necessarily the metrics or logs we needed. So there was a service falling over in production, and this was happening over a period of several months, where on-call engineers would be notified there's an issue with our ordering pipeline. They didn't quite understand what was going on. We had logs that was a stack trace, but not quite useful information. We also didn't have the traces related to this service. So talking about shifting left, well, we actually started from the right to debug this issue. Starting with the terminated service, user feedback saying I can't reorder, on-call engineers with their basically panicking for trying to triage this issue in real time in production. And we didn't quite know whether it was a scaling problem, an environmental change, or a bug in the code. So we clearly saw that the service was exiting, but we didn't really know what it was and why. We needed to add more telemetry to gain insight into what this exception was and get more information to our developers so they could triage this issue. So we caught this exception, and then finally got some useful metrics for our service, where it was clear which endpoint was being hit, causing for a particular request, which was the reorder endpoint. We ended up figuring out what exception was occurring. Effectively, what it was is a unhandled promise exception within the Node.js event loop, which caused the service to fall over, and we were able to work with the corresponding team to fix the problem and then address that bug. But again, we basically started from the right, went backwards as developers. We don't want to do that because it's clearly releasing bugs into production, again, impacting your on-call process, and we want to shift that as much as possible. So if we go down the pipeline of where we could have caused this issue, depending on how much you feel about TypeScript, we could have caught this at the type level. We could have introduced stricter types within our pipeline, as well as also stronger linting rules, because that would have also caught the bug. We could have added more observability into our tests. There were some tests that were throwing warnings saying that, hey, this test is failing, or this test is throwing a warning, maybe making our testing pipe a little bit stricter, and also observing the exceptions that were being introduced into production. So if a service was introducing more exceptions into production, we could have basically observed the change of a new exception being introduced into production. And then also providing more logs, which we showed on the earlier slide, where it was more useful to the developer that was on call. Because what we really care about at Sweetgreen is we don't want to go past the logging and metrics. We don't want to go past that because we don't want to release a bug in production to our users. So to start wrapping up here, what I want to reiterate is that a better developer experience will yield a better customer experience by tightening the feedback loop that you have between testing and observability. It allows you to iterate quicker and produce a higher quality product for your end customer. And what did this actually mean to our application in the wild? Well, with these software development changes and code-based changes and framework changes, we were able to increase our application rating on the Android App Store from 2.1 to 4.7, which is a major increase from before. We had a 400% increase in Android conversion rate. Again, major improvement from the previous application as well. And then it made it easier for us to do ADA compliance because we unified the framework that we were using. And for those that are unfamiliar, ADA compliance is for accessibility on your application. And that makes it so that, for example, screen readers, for those that need that assistance for using applications. So future opportunities for Sweetgreen, well, we're looking into adding more observability into our vendor integrations as well as our point of sale because, for example, we like mentioned before, we physically print shits during our end-to-end tests. We've had issues where someone walked by and kicked a point of sale that got them unplugged, and it took multiple hours to triage why our end-to-end tests were failing, so getting that more proactive into our pipeline. Investigating progressive rollouts so we can even completely bypass the end requirement for end-to-end tests in a sandbox environment for our software. And then since we're releasing development tools for our engineers, we want to track the usage of these tools and what issues they're running to on their local machines, or whether they even find the stuff that we release valuable, because they're also our customers internally to the organization. We're also looking into automatically tracking or estimating cost changes within our infrastructure, so like not just the response time of your endpoints or the quality of your tests, but how is the change you're making going to impact the infrastructure cost, because that also matters to the business. And then tying observability into our operational excellence program, so effectively you can monitor your team health from the processes they're working on, as well as the software health, and give them metrics to basically succeed as a team and not require an external organization to help guide them on what they need to do with their own software. And what does this look like? Well, we want to have a dashboard which identifies like mean time between failures, the cost of their applications, the response time, change lead time for introducing a change from basically your feature branch to production. And this will help us improve the organization, because what you're not measuring, you can't improve. And we'll be introducing this year at Sweet Green. Now to wrap up, I'd like to hand it back off to Borja to close us up.
So hopefully this gives you some ideas as to how you can bring some of the observability principles into the development workflow. At this time, Paul and I have happy to answer any questions, any comments, any discussion topics that you want to have around this topic. Thank you so much, everyone, for coming.